we've said that vectors have a magnitude and a direction. So we've got to wrestle with what does it mean that a vector has direction? When we think about vectors, we imagine them as arrows. Here's a car. It's traveling at 20 meters per second, and it's going east. Velocity is a vector, and we might represent it with an arrow pointing to the east. So I'm going to say to the right is the east. So we draw these pictures of arrows to represent vectors. So let's do a couple more examples. If there was another car that was going 10 meters per second, I would draw a smaller arrow. If there was a car going 20 meters per second west, I would draw an arrow like this, going the other way. Remember, a vector has a magnitude and a direction. When I think about magnitude, I'm thinking about how big the arrow is. When I'm thinking about direction, I'm thinking about what direction the arrow is pointing in. I could also have a car traveling south. So maybe I would draw an arrow pointing downwards, like that. So the vectors that we know so far are displacement, velocity, and acceleration. And I can depict all these quantities with these kind of vector arrows. The best way to improve your grade is with a practice test. On my site, I have a free Kinematics practice test. Click the link below to get yours today. Here's a house and there's 3 trees. 1 tree to the north, 1 tree to the east, and 1 tree to the northeast. And there's 3 people going for a walk. So let's say the first person walked to the north tree. We could say their displacement vector is 10 meters to the north. And this person's going to walk to the east tree. This person's displacement vector is 10 meters east. This person's going to walk to that tree over there. We would say that their displacement vector is 17 meters northeast. So remember, distance is a scalar and displacement is a vector. We always say that displacement is the distance between the 2 points. And here we see there's a magnitude and a direction for all of these. This direction is northeast. So the direction of the displacement is a northeast direction. The other quantity we can depict as vectors is acceleration. So let's say there's a car that's traveling on the road at 10 meters per second and it's going east. So its velocity vector is 10 meters per second east. And it just got on the highway, so it's starting to accelerate. So we could say it's going to be accelerating eastward. So we could say that it's accelerating at 15 meters per second towards the east. Now we could also imagine that later it's decelerating. So now the car is on the highway, it's going faster, but has to come off the highway, so it's going to decelerate. In this situation, there will be an acceleration, but it's going the other way. It's going west. So this is one of the key ideas we're going to wrestle with a bit more later, but acceleration can point in the other direction from velocity, and we call that deceleration. So here, the acceleration is taking away from the velocity, and it's going to be slowing down. In kinematics questions, we're always dealing with vectors, and often we use a convention of negative and positive. So let's imagine that there's a guy with a ball, and he throws it upwards. So he throws it upwards with an initial velocity of 10 meters per second. So here, I have actually set a direction, but I haven't written it down, and this happens often. The vector is 10 meters per second upwards, so the direction here is up. If we think about our 5 variables and writing them down, we should conceive of them as vectors. We're going to write the VI as a positive number, and in this question, we're going to say positive is upwards, and anything that's pointing downwards is negative. We might be saying, how high is it going to go? So the V final is 0. But the key idea here is that the acceleration due to gravity points downwards. So that means the acceleration due to gravity is negative. So acceleration is negative 10 meters per second squared, not positive because it's going in the other direction. The distance, the distance is up here. So that's going to be a positive number. I haven't calculated it, but we might say that the distance is 70 meters. So if I had said a negative number, that would be a distance downwards into the Earth. So if I'm starting here, a displacement that's positive 70 is upwards, a displacement that's negative 70 is downwards, down like there. So he's throwing it up, so the displacement should be a positive number. The other thing to mention is that time is a scalar. Time doesn't go north or south or up or down. Time is a scalar number, and we don't have to put a direction on time, which is nice to know. So in this question, there's a kind of implicit direction. Like we understand that we're saying positive is upwards and negative is downwards. So some teachers are more particular and need you to say 10 meters per second upwards, for example, to get full marks. And some teachers will be happy if you just say 10 meters per second and you understand that those are positive and negative. And your teacher will tell you what they want. Let's imagine another different situation where there's a person standing at the top of a cliff with a ball and they throw it downwards. And let's say they throw it with an initial velocity of 10 meters per second down. So here, I'm allowed to set downwards as the positive number. So I like to tell students, you can imagine you're God. You decide which is positive, which is negative. Right could be positive, left could be positive, up could be positive, down could be positive. You've got to decide, but you have to stay consistent with whatever you decide. So here, I'm going to decide that downwards is positive, so that means the acceleration is going to be positive 10 instead of negative 10. So the initial velocity is 10 meters per second, and the acceleration will be 10 meters per second squared. Now, what about the displacement? That's also downwards. We're starting at the top of the cliff going down. So say that displacement was 70 meters, that would be positive 70 meters because he's going downwards. The ball starts at the top and goes to the bottom. Also, V final is also going to be pointing downwards, and that's also going to be positive. So in this question, VI, VF, A, and D are all vectors, and they all point downwards, and so they're all positive. Again, the point is I need to choose one direction is positive and one direction is negative and stay consistent with what I'm doing. If you have any questions about this idea, comment in the section below.